Have you ever wondered where did gold come from? There's a massive asteroid between Mars and Jupiter that contains enough gold along with other metals to make everyone on Earth a multimillionaire. But what's the origin of this precious element? How did it form in the universe? Is there any connection of gold we see today with stars that died billions of years ago? If yes, then what is it? Understanding the cosmic origin of gold is no rocket science. If you look at the periodic table of elements, you'll find gold at the 79th spot. This means it's a heavy element. To understand where did gold come from, let's go back in time to the beginning of the universe. Soon after the Big Bang, only 3 elements were created: hydrogen, helium, and a trace amount of lithium. These elements were formed in the first 20 minutes of the universe. About 150 million years later, as the universe expanded and cooled down, the first stars were created from these elements. Stars are powered by nuclear fusion reactions in their core. The life of a star is a constant struggle between two opposite forces. On one hand, its self-gravity is constantly trying to crush the star, and on the other, the pressure generated from the nuclear reaction halts the collapse. Stars spend 90% of their life burning hydrogen into helium in their core. This phase is known as the main sequence. Our Sun is currently a main sequence star and will continue this phase for another 5 billion years. After all the hydrogen is converted into helium, stars continue to fuse heavier elements. Sun-like mid-sized stars do not have the potential to fuse elements heavier than carbon. But the more massive stars continue the process till iron forms in their cores. Iron is the last element that is fused by a star. That's because the fusion of the subsequent elements would absorb the energy, rather than releasing it. Once the core shuts down, the balance between the two forces is disturbed, and gravity gains the upper hand. The outer star layers fall toward the center with a speed that is 1/5 that of light. If the star isn't too big, the infalling layers rebound back after hitting the core, creating shockwaves and detonating as a Type II supernova. The energy produced in this event is so high that it forces the protons and the electrons to bump together and form neutrons. Being electrically neutral, neutrons are quickly captured by other atoms, forming heavier elements such as gold. When the supernova shockwave spreads the debris, these heavy elements such as gold are dispersed in the interstellar medium. From this enriched interstellar medium, other structures such as the stars and planets formed. This is probably how gold became a part of our planet. However, there's also another event that can lead to the creation of gold in our universe. That event is the powerful collision of two neutron stars. Neutron stars are the dead stars that have an extremely high density. Within a radius of 10 kilometers, a neutron star can encapsulate mass that is 1.5 times that of the Sun. In 2017, scientists detected a burst of gravitational waves from an ultra-powerful collision between two neutron stars for the first time. This event is known as a kilonova. However, the crash was remarkable in another way as well. When astronomers analyzed the wavelength spectrum of this explosion, it pointed at the presence of gold. It was estimated that the collision created about as much gold as the mass of the Earth. So definitely, not only are we made up of stardust, even the metal we adore the most is extraterrestrial. Share this video with your friends and in the comments section below, let us know what should be the topic of the next episode of Ever Wondered.